In this lesson, we'll take yet another look at learning and forgetting and try to draw some lessons for learners. And we're going to look at the research by Robert Bjork and his colleagues. Many neuroscientists and psychologists study learning and memory. He likes to think of his lab as also studying the process of forgetting. And in his view, there is this common knowledge out there that learning is the storage of information and forgetting is when that information decays. Seems reasonable. He argues that's it's not quite accurate. So he invites us to reconceptualize what forgetting is. And to understand that, we have to think of learning and memory as two processes. There is the issue of storage strength. So we can think of this as how well has the information been inserted into long-term memory, right? Installed into long-term memory. And then there's retrieval strength. And this is a measure of the ease of access to that information. But those are two separate things in Bjork's view. So when we don't use information for a while, so he argues disuse does not lead to decay in the storage strength of the material. Rather, disuse causes a decrease in retrieval strength, the current accessibility of the information. So forgetting is not information just decaying from long-term memory. He argues that forgetting is a loss of access, a loss of the ability to retrieve information that is there in long-term memory. So with these two concepts of storage strength and retrieval strength, we can set up this grid here and think about different types of memories that would fit into these different quadrants. So let's take a look at a high storage strength, high retrieval strength. This would be information, for example, your current address if you've been living there for a while, your phone number if you've had it for a while. You know it well and you can easily retrieve that information. Now that's in contrast, say maybe you moved 5 years ago or something, and 5 years ago you knew your old address very well, but maybe it's not as accessible right now because you haven't been there in 5 years, right? So because you have not used the old address for a while, we lose retrieval strength, although that information was well stored in your long-term memory. On the other hand, we might learn a new friend's phone number, and we just learned it and we're excited about it, so we have high retrieval strength for that information, but we've just encountered that information, so we haven't had time to install it sort of into our long-term memory. So we would say that has low storage strength but high retrieval strength. And then the low condition would be stuff that we learn during the day but forget, right? So we encounter information, and in some brief moment of time we have some access to it, but then we quickly lose that access, and we end up not really making much of a long-term memory out of lots of stuff that happens during the day. So Bjork has a theory of disuse then. So remember, we have storage strength, and he's going to argue that understanding what happens when we forget stuff, the storage strength determines the rate of loss of retrieval strength. And see, if we're losing retrieval strength, in a sense we're forgetting, right? So things that are well stored then, we're going to be able to retain access to that information. And that helps us understand, why do we forget some things faster than others? Because the storage strength is determining the rate of loss of retrieval strength. So if we haven't had a chance to store information well, then we're at risk of losing access to that information. We can see it graphically, storage strength on the bottom here, low, high, rate of loss of retrieval strength. So as storage strength increases, the rate of loss of retrieval strength decreases. Now if you sort of don't like that terminology here on the y-axis, we can change it to this. As storage strength increases, the rate of forgetting decreases. So of course the goal, if we want to retain information and have access to it in the future, we want to store the information well. When it's stored well, our rate of forgetting will be low. If it's not stored well, our rate of forgetting will be high. Now, how do these concepts of storage strength and retrieval strength, how do they relate to effective study strategies? So here, Bjork and his colleagues will make recommendations regarding study strategies and why certain study strategies are more effective than others. And here he's going to get tricky on us now. He's going to identify a counterintuitive relation. Now here it goes, and we'll say this a few times just to make sure we get this. The higher the retrieval strength of some information, the smaller the gains in storage strength with additional practice. In other words, when information is highly accessible, it is difficult to increase storage strength. Now, how does this relate to studying? Well, when we're studying, if we've been studying for a while and we're rereading our notes or rereading our text and so on, that's a condition where retrieval strength will be relatively high. And what he's arguing is that when information is easily accessible, then further study does not increase storage strength as much as when that information would have had low retrieval strength. Now, this sounds, counterintuitive, and we'll have to see what are the implications for studying.